So whilst they're loading, my name is Niall Murray. I'm a lecturer and researcher from Ireland. Um, my kind of area of interest is in human-centric immersive multimedia experiences and immersive multisensory experiences. So our focus is about how we can develop assessment methodologies to understand the user perceptual quality of immersive multimedia experiences. And we apply these across a range of different application domains, such as health, education, tourism, smart manufacturing, digital humanities. I'm still waiting for the slides. Are they coming?
I hope so. Just a second.
Hope so, yeah, no problem. So much of our research is actually quite relevant to what has been spoken about in the last number of talks from Linda, Vladimir, and the previous speaker, Victor. Yes. So you can move on to the next slide. So what I'll do is I'll introduce myself very briefly, where I'm from, and we'll get into the kind of more interesting stuff then. But first of all, thanks very much to the organisers for inviting me to give this talk. They've been very professional to deal with, and I think it's actually really nice we're trying to do these things in VR. So next slide, please. And you can move to the next slide. So what I will do is, on myself, as I said, I'm a lecturer. I founded a research group in 2014 called Truly Immersive and Interactive Multimedia Experiences. And I've been kind of looking at human-centric immersive experiences since 2010. I do this at a basic research level in terms of kind of frontier research through a number of different national research centres called ADAPT, which is the Irish National Research Centre for AI-enabled digital content technology, and in the smart manufacturing space through the Confirm Centre. And I also do some industry-facing collaborations with a national group called Command. So next slide, please. So this is where I'm from. This is Athlone. It's based in the centre of Ireland here, as you can see on the marker. Quite a small place, maybe 25,000 people, but it's very, very beautiful. So if you're planning on visiting Ireland at any point, please come to us. Next slide. We're known as the Hidden Heartlands. So in Ireland, a lot of the larger cities are on the coasts, but we have a lot of beautiful lakes and forests in the Midlands. And this is a picture of my institution here. And we're quite well known for multidisciplinary research. This is our kind of core focus. Also, our claim to fame is that we have the oldest pub in the Guinness Book of Records situated in our city. Next slide, please. So this is our group. So we are maybe 5 faculty, 2-3 postdocs, 15 to 20 MSc, PhD students, depending on when you visit us. And these are all the different teams that I'm involved in. I work for AIT as a lecturer, and I'm a researcher with all those other groups. So next slide, please. So we have quite a significant hardware suite funded through those research centres for the last number of years. And all of the HoloLens 2, HTC Vive, the Quest, which I'm wearing now. And then we have a lot of sensor technology. Our kind of focus towards the research is around data-driven user experience. And what we try to do is use data to infer user state, use data to infer user experience, and use data to infer how we should actually adapt the experiences in real time. So next slide, please. Next slide. So this is the framework we use. So this framework is called Quality of Experience. It was established as part of a EU cost action in 2010, I think. And this figure here on the left-hand side, what it shows is the range of different factors that influence perceptual quality of a multimedia experience, right? So the definition of QoE is the degree of delight or annoyance of a person whose experience involves an application, service, or system. So when we came and joined this talk today, we had some sort of expectation of what it was about in terms of the presentation of the content quality, the presentation of the interaction quality, the presentation of the presentation quality, right? We had an assumption or an expectation of what this is about. And through the figure on the left-hand side, we can classify different types of factors on how they influence or affect that user perceptual quality. Like some of us here are on PC-based experiences, some of us are using HTC Vive probably, some are using Quest, and so on and so forth. So each of those different types of HMDs or desktop-based devices result in a different user perceptual quality of experience. So that's an example of a suite of different device influencing factors. Of course, we're all distributed. We all have various network conditions. Each of these factors will affect the presentation quality or the QoE of this particular experience. So this is multidimensional and multifactorial, and it's quite complex to measure, but it's also very powerful if we can do it well. So this is what we do. We do QoE of immersive and multisensory experiences. So next slide, please. So how do we do this? Our core focus is on how can we assess the user perceptual quality in an ecologically valid manner, right? The classic approach, Linda earlier on talked about using user tests. Vladimir talked a little bit about using user tests and things like this. The classic approach to user perceptual quality evaluation is via questionnaires or surveys post an experience. And these have been defined, across all types of multimedia experiences, whether they're ITUT or VQuag or whatever other standardization groups. What we have tried to do in the last number of years, and I'll talk about it on the next slide, is define new methodologies for this. So when do we ask the questions? What questions do we ask? So this is the qualitative approach. And primarily, our core focus at the moment is on quantitative data infers user perceptual quality. And we try and do this, as I said, across a range of different application domains. So we had a very similar project that compared to what Linda talked about, comparing haptic and AR to improve users' gait and these kinds of things, right? So I'll talk about those in a couple of minutes. So next slide, please. So how do we do this? So we still adhere to traditional approaches. We still capture user self-reported data through surveys, questionnaires, or open-ended questions. But we also capture, and we use this presentation technology as a sensor. We use the sensors available in the devices to understand head movement, to understand interaction metrics. So how am I moving my hands? How am I moving my body? We use sensors that are embedded in these devices to capture eye information. And if we have, depending on the context of the actual experiment, is there a performance rating that we can classify for the users? And I'll talk about this in a few moments. And our motivation is to migrate towards continuous quality data capture. That's what we're motivated by in our group, so that we can quantify the user quality of experience. Okay, I hope this is clear. Next slide. And next slide. So in the context of doing that, in the context of capturing all those metrics, and in the context of the different types of data we capture, I'm going to talk through a few different projects we have run over probably like the last 10 years now, I guess, at this point, right? So this is a virtual tourism experience, which involved virtual reality, but it also involved haptic or sense of touch as a media component, and it involved olfaction or the sense of smell as a media component. And the question here was about what is the utility of adding these multisensory components to an experience in terms of user enjoyment, but also information recall on the environment. So if you move on to the next slide and play the video, we had three different groups. Click on the audio, please. We had three different groups who experienced immersive virtual reality only, immersive virtual reality plus haptic, and immersive virtual reality plus olfaction. And you can see here the rig on the left-hand side was a virtual Segway that we built and designed. Under the boards were motors that gave haptic feedback when the cannons went off or when you were actually navigating around the experience. And as the cannons were going off at different points in the experience, olfaction or the sense of smell as a media component, which was presented based on the context of what the user looked at was also presented. So we ran like a large-scale set of user tests with 92 users on this, captured a range of different metrics on the users to try and understand if there was any utility in presenting these multisensory components. And haptic was reported as the one that was highest levels of enjoyment, and smell, not surprisingly, aided with the information recall. So next slide, please. So someone had a question earlier on about using, or a comment earlier on about using VR or AR for language development, right? So my wife is a speech and language therapist, and she works with clinical cohorts all of the time, and a lot of the key part of her job is assessment, and another key part of her job is interventions, right? So with speech and language, there's the assessments whereby you're trying to evaluate the ability of people to receive language, or their receptive language, which is what everybody here is doing now except me. The only person who's not undertaking a receptive language task is me. I'm doing an expressive language task where I'm actually communicating, right? So the receptive language is about how can we understand vocabulary and language, and there's a clinical test called the CAT, it's comprehensive aphasia test, that if someone has a traumatic brain injury or a stroke, they have difficulty in linking vocabulary. So their ability to retrieve vocabulary is diminished. And in the CAT test, there's a battery of tests that clinicians run to try and assess the level of impairment post an injury. And one of these is semantic memory exercise, whereby the aim of the task is to link appropriate vocabulary. So obviously the eye is directly associated or semantically linked with a pair of glasses, not so much so with bicycle or a chair. So the assessment involves asking users to go through a suite of different assessments like this. And currently in the clinic, these are paper-based, right? So when we digitalize it, we can capture information like you can see on the right-hand side through eye tracking. We can capture saliency maps, saccades, facades, so on and so forth. And it moves us beyond, and if you want to move on to the next slide, please, it moves us beyond this binary correct or incorrect. And this is where the power of these immersive technology resides within clinical settings, which touches a little bit on what Linda talked about earlier on. So this is a colleague of mine. He was my PhD student at the time, Connor. He's now a faculty member working in our faculty. And you can see this is this was the HoloLens 1s, I think, at the time. So he digitalized the assessment and the interaction, because the actual real interaction is point-based as well. So in the paper-based assessment, the users point, which is a nice way of doing this. He created an equivalent virtual reality experience, and the room was one-to-one mimic of the real room. And again, you'll see him pointing and interacting with the virtual content, as was the AR. So we did an evaluation on this on AR, VR, or tablet to see what the utility of applying this technology was. So next slide, please. So another nice example where we have applied technology in the health domain is around an immersive wheelchair simulator. So one of my PhD students, Deborah, is working on this, and she developed this obstacle course, I suppose you could call it, because data from the WHO has identified 3 key areas where it's difficult to learn to operate a electric wheelchair. One is going up a ramp, 2, navigating a course which involves lots of tossing and turning, or 3 is entering an elevator. And Deborah built this system which included haptic feedback with a real joystick to evaluate the user perceptual quality and utility of VR as a tool for training a user to operate an electric wheelchair. Next slide, please. So I also do some work in the smart manufacturing space, and this is a very simple AR application to operate an injection molding machine. And the kind of idea is, can we use AR here to help users to operate these machines with basic knowledge, or to use AR to solve quite bespoke, complex problems. And the Rubik's Cube is a lovely scenario here, whereby there's so many different combinations of how or where it starts from. It's almost a bespoke problem each time. And how can you actually solve it in a number of steps is, we did a QE evaluation on this using AR. So next slide, please. And again, in the smart manufacturing use case, teleoperation is another classic use case, remote maintenance. And this is actually happening in reality in terms of in industry. Industry use VR for this. There's a company I work with not long who used this. So this particular scenario here was a VR replication of an injection molding machine and how to use it training scenario. So again, we captured all the different metrics on this, and we looked at the impact of delay on this. You can move on to the next slide, please. Of course, as the world becomes more and more autonomous, you can use virtual reality to recreate a suite of different scenarios and situations whereby it's not safe to test with users, essentially. Lots of research has been done with using VR to train camera-based systems for autonomous vehicles. Not as much research has been used looking outside in, looking at the user in this autonomous vehicle's experience. And this was the kind of core focus of this test. So next slide, please. And this is another example of in smart manufacturing, whereby we use the HoloLens 2 this time to operate or control a virtual robot arm, specified a particular waypoint, ensuring that that waypoint specification doesn't cause any collisions with any objects in the real world. If it does, don't communicate the instruction to the real robot. If it doesn't, communicate. Which is a very applied, nice industry-focused project. Next slide, please. Okay, so everybody talks about you're primarily in terms of the visual, right? And I've talked already today about how we use immersive multisensory systems in terms of olfaction or haptic as a media component. But another key modality in these experiences is spatial audio. And this is a PhD topic I have running with Adrieli, who is funded through the ADAPT Center. And she's looking at how people react to audio stimuli in VR to try and, because it's really important to understand the effects of all of the different modalities in these experiences. So next slide, please. And we can jump past this one because I know I'm under a little bit of pressure for time, but it's another example of, someone had a scenario there about using VR for construction earlier on. We do this all the time as well in terms of creating the environments, particularly dynamic environments, and it's quite useful to do this in VR. So next, please. So I guess the kind of concluding points here is that, critical to the success of these immersive and multisensory applications is user-centered design and understanding user perceptual quality of these multimedia experiences. So that informs the design process, it informs the development process. All of the time, we design, we develop, we test, and we work in that loop continuously. I think Victor spoke about the volumetric video there earlier and talking about use cases and trying to find a kind of killer app for this. And I often hear that we haven't found a killer app for VR or these kind of experiences yet, but there is no killer app because it's so applicable across a range of different application domains, whether it's what Linda talked about with the health, it's what I talked about here in the smart manufacturing, someone else talked about in the education, the tourism. It's applicable everywhere if it's done really well. And you can actually achieve enhanced utility by digitalization of a number of these different application domains and capture different data that you can't get in the real world, which is quite powerful. So that's the kind of concluding point. The last slide, I think, is in the questions. So I hope you could hear me okay, but I'll take some questions now if you wish. Thank you.
I'll try to bring the microphone around. Questions, anyone?
Feel free to, while we're waiting for the questions, feel free to reach out to me. You know, I'm very much open to collaboration and, you know, projects and things like this. I do a lot of these across different groups in Europe, across a lot of these different application domains. So, you know, I'm a nice, friendly person to work with. Okay.
It does look like that. While we're figuring that out, okay, someone else goes, please.
I have a question. In your, I mean, first of all, thank you. Awesome work you're doing, and I was just curious. Have you tried to see and identified any like differences in audio influence in VR and AR? Because I mean, in my studies, we saw really extreme importance of the audio, and of course, it's because of its physical therapy. You can't do that without audio, but I mean, in general, because it's also connected to the visual inputs. So yeah, have you seen differences in VR, AR?
So, in differences in terms of what exactly?
Of the audio, how people perceive audio inputs, if
Yeah.
they are in VR or in AR.
Yeah, so the first point I'd make is, like, I think the application of audio in AR is actually really interesting. And it's something that people overlook a lot because they're kind of going, well, if you're in AR, you're in the real world still, you'll still have the audio stimulation, right? But I think that's a really interesting element. In terms of VR, so one of the evaluations we have done is we have tested the impact of different types of audio on visual attention in 360 video and visual attention or not visual attention, performance in a task in VR. So there are two studies we've run, right? So what we've done in each of those studies is we had spatial audio, first order ambisonics, third order ambisonics to look at where the user looked in the 360 video based on the presence or the source of the audio stimuli. Now, this is quite useful to know this kind of information, or because it will allow you to predict where the user will look from the visual perspective, right? So in a multimedia streaming scenario, and again, Victor in the previous talk talked about, you know, these kind of experiences, streaming or delivering this kind of content is quite challenging. So if we can predict based on regions of interest in the visual and source of audio from the audio perspective, we can predict where the users will look in advance and only stream this at high quality, right? So this is obviously important. In terms of the VR study we did, what we did, we introduced different levels of noise into the environment to see what was the impact of this on the user's ability to identify the source of the sounds, right? Because even in this experience here now, it's quite quiet, right? But there are, I can hear noise in my own background here. I can hear bits of noise in other people's backgrounds, right? And that affects where we look and how we behave in the environment. So in a range of different tasks, this is quite important. But I'm happy to share this kind of stuff with you, Linda, afterwards if you want to reach out to me. There's no problem with this.
Yeah, awesome. So thank you again very much. Dr. Murray, let's give another round of applause, and we'll have our the last speaker here on the stage, please.
Thank you.